Welcome to our next lesson, limits of graphs. So we're really going to be fleshing out that notation of limits today and specifically looking at the visual representation of limits. We've got a couple screenshots here from a textbook that I like to refer to. So you'll see notes a little bit like this throughout the course. We'll just kind of be working with them as our notes. And then from there, I'll be posting worksheets. So there is a worksheet posted for this lesson already in our OneDrive, and I'll show you where to find that again at the end of the lesson in case we need to figure that out. So limits of graphs. So we're going to be doing this visually, looking at graphs, but also really truly defining what a limit is. So when we look at all three of these functions, they definitely have some similarities, but they are not quite all the same. So when we look at h of x, this would be our most commonly seen function as we've gone through high school, just a straight line with that defined point at 1 and 2. So if I asked you to define what is the limit as x approaches 1 of h of x, you would be able to look and you would probably say, well, it's 2, because that's where there's a dot, that's where the line is approaching the dot, and so 2 is our answer, and that would be correct. Okay, because again, remembering that our limit is really just the y value at whatever x we're approaching. Okay, so this one's predictable, it's right there, it's defined, it's a point, but we move over to the left and we see the second function. We're like, okay, well that's kind of great, but there's a point down here and it's defined at 1 but not the same. So that's where we get a little bit murkier. Is this a limit? Well, if we looked at the function and we said g of 1, we would say 1. And if I asked you what the limit was, though, as x approached 1 from the left, what we would say is for g of x, don't forget the function part, that means that we're coming from the negative end toward our value. So again, on our x-axis, that would mean we're approaching from the negative side, going from the left. Okay, so that's what that little notation means, the superscript. So if you need to make a note of that to yourself. Superscript of a negative means that we're coming from the left. Okay, and so when we look at our graph, as we're coming towards 1, even though 1 is technically defined down here, as we're approaching 1 from the left, we would want to say 2. And so that would be our answer for this limit. Even though technically it's defined at 1, like y equals 1, because our whole function is approaching 2, that's where we would predict it would be from the left. The limit as x approaches 1 from the right of g of x, well, means that we're coming down from the positive end of our x values. Okay, so coming from the right there. And again, we're approaching 1 from the right. In this case, we're coming down, down, down along this line, and we're still approaching 2. So again, the answer would be 2. Because of this, if I asked you the limit as x approaches 1 and I didn't give you some directionality of g of x, you would be able to say, oh, well, it's 2. So even though the value of the function is 1, the limit is 2 because that's the predictability piece. So again, where it's kind of approaching as we come towards that value is more important than the actual value of the function when we're given the x. So bearing that in mind, we can look at this third example and we see, okay, well, this is f of x. It's entirely undefined when x is 1. But again, if I look at the limit as x approaches 1 from the left of f of x, we get the same answer as g of x. We get 2 because we're coming from the left toward 1. If we do the limit of x approaching 1 from the right, coming this way, again, don't forget your function. Well, we're coming down and we would expect the value to be at 2. So given that the left and the right limit are both approaching 2, even though it's entirely undefined, and if I asked you for f of 1, you would say it does not exist. Okay, the limit as x approaches 1 of f of x, looking at the behavior of the graph around that specific point, it does exist. It is still at 2. And so that's what happens here. So for all three of these graphs, even though we've got a hole with a distinct point, and then we've got a filled in point, all three of these graphs still have the same limit in spite of these kind of discontinuities that happen. So in math jargon, this is the definition of a limit. So we would read it as basically saying that the values of f of x of the function f approach or equal L as the values of x approach but do not equal c, bearing in mind that c has to be within the range that x exists on, and basically that L has to exist within the function also. So it's really, really jargony. The notation is quite confusing. This is maybe a little bit more user-friendly. The idea that as the limit as x approaches any constant for a function will result in some value L, which we call the limit. So that's all great, and that sounds kind of nice, but we're going to add some other caveats to this. So first of all, I'm going to translate this into some more user-friendly language, and the idea is that if we are taking the limit of a function, or the limit results from taking the limit. So L, the limit value, results from taking the limit I'm going to zoom out a little bit for this. Of a function as x approaches some constant. And again, x is used to represent the independent. Okay, so it doesn't actually have to be x, but most commonly that is what we use. Now, within that, there are a couple of big cases to note, and that basically was demonstrated by what we saw up here, is that any limit is defined by the behavior surrounding that point. not the value itself. So we'll do an example here to kind of cement what this exactly means. So when we talk about limits in general, we'll use this graph for all of these questions. So for one, if I asked for the limit as x approaches -4 in general of f of x, well, that's probably one of the nicest questions I could ask you, because if I look on my graph, I can see, okay, if I follow from the right, it approaches -4. If I follow from the left, it approaches -4. And just the general value of my graph is defined at -4 in the same place that those two pieces predict. So when x equals -4, my limit is defined and it's going to be +1. Okay. Just to practice again, we've got the limit as x approaches -1 of f of x. Well, at -1, we've got from the left, and so maybe we need to consider both cases. As x approaches -1 from the left of f of x. Then we've got a value of coming up to +4. The limit as x approaches -1 from the right of f of x. We look and we go, okay, well, as we come closer to -1, bang, it also looks like it's going to +4. Therefore, the limit as x approaches -1 of f of x equals 4. So using our definition, what we can say is that a limit exists if the left-handed limit and the right-handed limit are equal. So again, we see this kind of denoted by saying that the limit as x approaches c, if we want to get into our math language again, of f of x equals L, if and only if or it's implied that it exists, rather, if the limit of x approaching c from the left of f of x equals L, and if the limit of x approaching c from the right of f of x equals L also. Okay, so it exists if it's approaching from the left and approaching from the right. And we totally disregard that the fact that for this example at -1, this function is technically defined at x equals 1 as being +1. That has no bearing on my limit. It's just how it approaches it that I care about. So if we look at question 3, the limit x approaches 2 of f of x. Again, we go, is it defined there? Because that usually makes things easy. No, but it still follows that predictable behavior from the left, we're going down towards y equals 1. From the right, we're going up towards y equals 1. So our limit will be 1. And again, you can show that our proof is because the limit as x approaches 2 from the left of f of x equals 1, and the limit as x approaches 2 from the right also equals 1. Okay, so you didn't have to do all this work. If you just looked and you saw, that's good enough, because I wasn't asking you to prove it. But this would be our final answer, and this is why. 4, if I ask for the limit as x approaches 3 of f of x, well, that one gets a little trickier. As we approach 3 from the left, we're heading down, 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 forever downward at an asymptote. And what we know about vertical asymptotes is that we do not cross them. So this is going to forever get closer and closer and closer to negative or to positive 3. We're never actually going to get there, but the graph is going to continuously go down forever, which means that on my left-hand side, so my left-handed limit, and again, I'm going to just kind of draw a line here. So limit as x approaches 3 from the left of f of x is going to be negative infinity, going downwards forever. My limit as x approaches 3 from the positive side of f of x, so from the right, going down, 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 and it also is going down forever as it approaches that asymptote. So because both of these agree, my limit of as x approaches 3 of this function is going to be negative infinity. And that'll be my answer. Okay, so again, it might not be defined there might not be a value, but it can still exist as a limit. Question 5. Limit as x approaches 5 f of x. Well, you look here, this is where it gets tricky. We're looking as it approaches from the right, and it equals -1. Approaching, or from the left, sorry, approaching from the right, it equals +2. So because those two limits do not agree, 5 from the left equals -1, and the limit of x approaching 5 from the right of f of x equals +2. Because these are not in agreement, it does not exist. Okay, so very, very important piece of this law. Okay, so the left-handed limit and the right-handed limit have to agree for our limit to exist. So if they don't exist, neither does the actual limit. Each one of these do exist. The left-handed limit and the right-handed limit both exist independently, but on the whole, now we do not have an answer. Okay, now if we go back and we look at the actual values, it's important to note that even though at limit of x approaches -4 of f of x, it equals 1, f of -4 also equals 1. Right? You can write here on our graph, -4, +1, boom. But again, please note that that is not always the case. And f of -1, well, that actually would be not +4, but +1. Just add that out anyways. Okay, so again, going over here, if I just asked for f of 2, well, that actually does not exist. And if I asked for 4 just for f of 3, that doesn't exist either. And as the limit approaches, if I asked for f of 5, it does exist. It would be 2. So we can have cases where they match perfectly. We can have cases where my limit does not match my value of the function. We can have cases where the function doesn't exist, but the limit does. And conversely, we can have cases where the function does exist, but the limit does not. So all of these are different kind of scenarios. But the key to remember, if you take out only one thing from this whole lesson, is that left-handed limit and right-handed limit have to be equal in order to make this limit exist. So again, the limit exists if we see that the left and the right are both in existence. And that little negative sign is telling me approach from the negative end of my x-axis. The little positive sign is saying approach from the positive end here. So there, again, there's a worksheet, and I will show you quickly where to find that. So if we go to our folder, so you'll open up your calculus folder, you'll go into limits, and if you scroll to the bottom, there is a worksheet here called Worksheet Limits of Graphs. And you can print it out, or you can just kind of look on the computer and then work on a piece of loose leaf. And once I finish making this video, I'm also going to be uploading it into our course OneNote, and so it'll show up right underneath here, so you'll be able to access it through there if you don't want to have to go searching through the files. I hope that makes sense. Please email me if you have any questions. Also remember that you can post questions that the rest of the class can help you with. I see that no one had questions for the pre and review, but if you post any questions here, it's just a matter of going in and being like, hey, I'm not sure, oops, if I can spell that would be great, about the answer to 6b. Anyone explain how to do this? And if you post this question, then either one of your classmates or I can go in and be like, oh, well, let me help you with that. So just a quick reminder that that actually exists. I'll delete that question because I don't need you responding to it. But again, that's under collaboration space. Content library is where you're going to be able to find all these notes. So if I go back in, I see limits of graphs, and again, I can see everything that's written all at once. So if you don't like listening to my voice, or you just want to quickly see one little piece of it, you can go here instead of having to like search through the video. And again, that worksheet's going to show up right over here. So good luck, and if you have questions, make sure you use all your resources.